Okay, my thesis is about application of BIM for bridge monitoring. So as an introduction, it's important to point it out that bridges represent an important role in road systems. And like other infrastructures, they also suffer from external conditions, dynamic loads, and all of this leads to gradual deterioration. It's important to assure safety of these infrastructures. So my research objectives, they were related to investigate the efficiency of monitoring system currently used, explore the BIM uses in bridge monitoring and maintenance, and integrate BIM bridge monitoring through a GIS system. Currently, there are two types of techniques to do inspections, which is the interval-based techniques that includes routine visual inspections, and other types of non-destructive inspection techniques like ultrasonic, acoustic emission, laser, and the condition-based techniques, that is the structure health monitoring. It's more currently using like sensors that they stay like on the bridge to do the ongoing monitoring. This part includes like the choosing of the right sensors and gathering data, organizing the data to finally examine it and repair. But these approaches, they have limitations, like the sensors, they need to have resilience to external factors and logistical limitation as well, susceptibility to alterations in input data, and sensors reliability and drifts over time, which is like the gradual declining accuracy on sensors. And the visual inspections, they strongly depend on human assessment. Inspectors, they can classify the same deterioration differently. So for this research, we took a case of study of a bridge in Slovenia. It's a viaduct divided in two. These are the original files that the government provided to us. So it was divided in viaduct A and viaduct B, and here you can have like some notion about it. This is the cross section. In the reports, there were also reports about the previous inspections, visual inspections that were made on this bridge. And they drew, this is all files from the government, they drew the damages here and how to approach and repair it, like removing damaged concrete with water jet and replace parts of the bridge. So to do the integration with GIS, it was needed to model a simplified 3D version of the bridge. To do that, I used InfraWorks, and here there are like some parameters and properties that I had to alterate to look more similar with the ones from the files of the bridge. And then after that, I needed to export to Autodesk Revit, because for the GIS we use Dalux and it only accepts IFC files. So it was not possible to export directly from InfraWorks. After that, it was made a visual inspection to collect data of the bridge conditions now. The methodology was divided by first inspection of wings, piers, girders, and then pedestrian areas. We only did like substructure because there was traffic along, so we would need to close the entire bridge. Here are some pictures about the corrosion on the girders and piers. And also retrofit works were already made on this bridge, as we can see. And then after that, all of these documents, the previous one from the government, the 3D model, and the pictures, they were uploaded in Dalux software. And they appear, like I can add the pictures straight from the location, or I can also go to the bridge and just take pictures and add to the location where I'm exactly at. So this is like the points there, they represent where the pictures were taken, and so you can like localize yourself exactly where was the damage or the condition of the bridge. And through Dalux integration, you can also take 360 pictures, which was made also there. it shows as a dot on the map, and then you click and you can see the 360 caption of the bridge. And I also created, this is like the application. Yeah, there was also a form that was made so you can reply when you were like doing the inspection to classify and say more about the condition of the inspection of the bridge parts. You can create how many forms you want, and then you can just answer there, and it will show to all the stakeholders of the project. This is the desktop version. There's also the iPhone or Android version. So you can just do it like on your phone when you're visiting the bridge and answer the forms. Here are some questions about general condition. Is the bridge free from visible damage or defects? Signs of settlement or movement, visible rehabilitation work, retrofit. Is there any damage on the rehabilitation work? And then in the end of this form, you can also add recommendations, as if like a part is too damaged, you can require a different inspection or some rehabilitation work. Here, I'm just showing a bit more about the iPhone application version. You can also add tasks, the forms, and the pictures. The pictures show up like this. If you have a dot, you can add several pictures related to that specific point of the bridge. And then later on, you just click and then you can see like all the pictures made from that location. So through Daleks, it's possible to centralize the data, and you can also use the app offline and then upload later also. And it's possible to do a more predictive maintenance, detect anomalies and structural issues, 2D, 3D integration, and yeah, this is a sum of the assessment of the Dalux. And here are some conclusions and limitations. The good part of using it is that you can always monitor the bridge, and when you upload, it's immediately available to the other people involved on the project, so they can also see it. It's possible to do a bit more of like, you don't need to be exactly there. Someone can do the inspection and the pictures, and the engineers can look after. And also, yeah, centralized data is really important in BIM, because the files of the bridge, they were all a bit lost, like just 2D, and like everything was a bit complicated when I took the files, because everything was a bit lost, and you don't have like a centralized place to just look at all the files from the bridge. And for future work, I would recommend focusing on explore integration of GIS through BIM, the maintenance and rehabilitation phase, and more. Yeah, for this project, I didn't have access to sensors of the bridge, so I couldn't do the integration with sensor data. But it would be more interesting if we had like sensors related, so we could like also add to Dalux.